Good afternoon. I would first like to thank the meeting organizers for this opportunity and all of you in attendance today. I'm going to talk about a dye trace investigation that we conducted just down the road near Frankfort in collaboration with the Kentucky Geological Survey and Castle and Key Distillery. Kentucky karst geology is inextricably linked to one of America's most distinct distilled beverages, bourbon. This unique combination of groundwater chemistry, fertile soil, temperate climate, and the settlement of the Commonwealth by expert distillers has played an enormous role in our culture and history and continues to influence our modern livelihoods. Karst is Kentucky's geoheritage. If you're working in water resources, which many of you in the room probably are, you're aware that over 50% of our state is underlain by soluble bedrock, primary limestone, and this is characterized by subsurface water flow that creates caves, springs, and sinkholes that form these beautiful rolling hills of the Kentucky Inner Bluegrass region. It is not by chance that most of our distilleries are also located here as well. In fact, the Kentucky Distillers Association reports that 95% of the world's bourbon was produced in Kentucky, and in 2023 reports more than $9 billion of economic benefit to the state. The crux being that this unique karst landscape and the water resources within are extremely vulnerable to land use impacts. To protect our natural resources, cultural heritage, and current economic benefits of both, we must understand land use interactions and water quality conditions. In 2022, Castle and Key Distillery reached out to several organizations for assistance in understanding the recharge area for Old Taylor Spring, which is the main source of water for distillery operations. Not only were they interested in how water quality, but also the observation of the spring that had decreased from 150 gallons a minute to zero flow. And though that's not highly unusual in karst springs, it is unprecedented at this spring and markedly different from the historical and modern observations up until that time. So with this in mind, we designed a dye trace investigation to identify groundwater flow paths and potential threats. So Castle and Key here is located just south of Frankfort. It's near the Franklin and Woodford County line. And you can see it's south of I-64 and really down gradient of developing areas in the city. Specifically, we're concerned with the area here. As you can see, development has continued to occur, and all of the area that was designated as industry or industrial zoning has reached capacity as of like 2018. And so now what we're looking at is potential rezoning of ag areas to help. So you can see right there that area here is what we're concerned about. And while some of the developers may have questioned it, this is definitely a karst area. Specifically, it's underlain by the Tanglewood member of the Lexington limestone. And you can see that this has sinkholes, I can't see that, but it is known for sinkholes, underground cavities, and springs are very common in this unit. And you can see that these are also interbedded with shales. And so that does play a part on how water flows through the area, and you can see here in this more generalized diagram, you get that stair-step effect as it goes through the limestone, and then more silty or shaly layers might cause some surface flow, and then it disappears again. And so this is just your classic inner bluegrass karst and how this conceptually, what's going on in the subsurface. Now, much work has actually been done in the inner bluegrass area and around Frankfort when it comes to dye tracing. And specifically, the Cedar Cove Basin was delineated back in the late 90s. And you can see that most of what we're calling the developed area here, where there's urbanization and industrial areas, is shown to drain north. However, this large southern portion here of south of I-65 was interpreted without any actual field testing, and this was based on the geology and surface topography. But because of these marked changes at Old Taylor Spring and the continuing development in this area, we really wanted to confirm that boundary and make sure we understood what surface areas were indeed recharging to the north or those that may be actually flowing south. Right here is where Castle and Key is and Old Taylor Spring, down here at the base of this big drainage. Is that impacting Glens Creek to the south? So as in any dye trace, we have to get boots on the ground, not only to find these resurgences, but to investigate where we want to place the dye. And so we're looking for different points such as sinkholes. But these images here are 3 of the groundwater, points that on Castle and Key property that we did monitor. You can see Old Taylor Spring here in the center, and some other points on the property where groundwater was issuing, or we have a well in order to monitor that. Now, we did spend a lot of time in the area, but access was limited for several reasons. There were some road closures, there's private property issues, there's also a large quarry operation. So you can see all our monitoring points here along Glens Creek. We have some over this is Vaughn Branch, which is also flowing to the Kentucky River. And up here we have Cedar Cove Spring. So the first injection we did, of course, this was kind of to the east, well within the Cedar Cove basin as it was mapped. This is a large sinkhole, actually acts as a karst window at various times of the year where water is resurging on one end, flows across the bottom of the sinkhole, and then sinks right where you see me pouring this fluorescein dye for this particular test. We did eosine, and again, this was really nearest the developing areas. What you can see as you look behind me in this photo here where we're pouring the dye, right past tree line is the fence line that is now kind of the border of what is ag or industrial or the zoning line that was in question for these properties. So this one was the closest that we could get to that area. And did an eosine injection here into this sinking stream. This sometimes has surface flow. This time of the year, it's disappearing into the ground just there in the photo, just a few feet below where we poured it. Then we also did a rhodamine WT injection along the possible western boundary. There's not really been any injections over there. This was a large sinkhole complex out in a neighborhood, so you only see this, this one opening that we're injecting dye into, but there were actually several openings in a large complex here as well. So these are our final results. As expected, we did see fluorescein at Cove Spring within the first really week of sampling. And so that map, that basin that was drawn in the 90s, can be confirmed by that trace. However, you can see where we injected eosine just on the other side of that boundary. So there is some still room here for some refinement along that area if there was access to the industrial park there for additional work. But at this point, that line seems to be most appropriate, again, based on the geology, topographic, the surface topography, as well as these dye trace results as to what we had access. So the eosine did go to all groundwater monitoring points at Castle and Key Distillery. Unfortunately, the rhodamine WT trace was inconclusive, but what we do know is that it did not go to Castle and Key. We did not see it at the other large springs on Glens Creek or in Glens Creek proper. We did not see it on Vaughn's Branch, but that does not mean it might have come in. It might have researched at a different location. It might have researched somewhere in the quarry, we're not really sure. So it is at this point we have no dye recovery, and that is inconclusive. But of course, urban development was the impetus for this, and so I think it's very important to say, well, while we do have more info in this area for the distilleries, in addition to Castle and Key, there are multiple distilleries along Glens Creek. There's also a lot of agricultural tourism. And so this is important. And so now we can better manage and protect those water resources that really sustain the foundation of Kentucky's geoheritage, which is karst landscapes. So thank you again. Please reach out if you have any questions or would like more information about karst landscapes or fluorescent dye tracing. Many thanks from Crawford Hydrology Lab.